Electric motors are machines that use electricity to create motion. They come in various sizes and are used for many different things. But how do these electric motors actually work? Let's start off by taking a look at this wire. This wire is made out of copper, which means that normally the wire isn't magnetic. It cannot attract any magnetic objects, and it also cannot get attracted by a magnet itself. The story changes when you make an electric current run through the wire. When you do so, a magnetic field is created around the wire. Suddenly, the wire has become a magnet. When the power is turned off again, the wire is no longer magnetic. Now let's say we put the wire right in between two permanent magnets. Obviously nothing happens since the wire is made out of copper. But now let's make an electric current run through the wire again in the direction of the red arrow. As we just discussed, a magnetic field is now created around the wire. This enables it to interact with the two permanent magnets next to it. The question is, what is then going to happen? Will the wire get attracted by one of the magnets? Will it get pushed away? Or maybe will it stay right in the middle? Well, in order to figure that out, we've got this model. It's called the motor rule, and it tells us which way the wire will move. The magnetic field is directed along the black arrow from north to south. The current flows in the direction of the red arrow, and this means that the wire will get pushed up in the direction of the green arrow. The force pushing up the wire is called the Lorentz Force, and it's the force that drives electric motors. Now that we have this knowledge, we can understand how electric motors work. Right here you can see my drawing of one of the most basic electric motor designs ever. We've got a coil and two permanent magnets. The magnetic field goes from north to south, the direction of the black arrows. Now let's make electricity run through this coil and take a look at this side of it. As you can see, the current flows in the direction of the red arrow and the magnetic field is represented by the black arrow. This means that according to our little model, this part of the coil is going to get pushed down. The opposite is true for the other side of the coil, which gets pushed up. And when one side goes down and the other side goes up, the coil rotates. But unfortunately, it only does so for a very short while. It will only rotate 180 degrees, after which it stops rotating. Why is that? Well, the coil has now reached a point where the top part is being pushed up and the bottom part is pushed down, which means it won't rotate anymore. It's now in the ideal position. In order to make it rotate, we need to reverse the electric current in the coil every time it completes a 180-degree turn. Fortunately, there is a very clever little system that can be used to do this. This wheel consists of two halves, and these two halves are connected to the two leads of the coil. When the coil rotates, the wheel also rotates, and when it does so, it automatically reverses the electric current every time the coil completes a 180-degree turn, as you can see in this animation. And that way, the coil keeps rotating. That's how electric motors work. Now, there are many different types of motors, many different designs ranging from very simple to very complicated, but they all rely on the same principle. I hope you've enjoyed this video, and thank you for watching.